Thank you so much for the opportunity to be here. This is really a treat. There we go. So a bit about myself. I was the original architect and developer of the XNAT platform. I was tasked with that about 20 years ago and designed and wrote most of the platform that's still in use today at hundreds of research institutions around the world. I was the tech lead on the project for until about 2012 when I left and joined Dan at his startup as co-founder and CTO. And then when we merged with Flywheel, I had the opportunity to rejoin the XNAT team for the first time in years, which was a great treat. I got to get back to some of the old code that I'd written and update it and improve it for the modern usages. And that's what I've continued to do. And then last year, I founded a new company called XNAT Works that's specifically focused on providing development and support for the XNAT platform. It's me and my family. Oh yeah, that's the earliest picture we could find of the XNAT team there on the top, Dan sitting down, me standing up, and Mohana next to us. So that was, the three of us were kind of the original XNAT team for the first several years. So yeah, the XNAT Works team is pretty big. We've got over 200 years of experience on the XNAT platform. We have the lead developer who took over after I left the group, Rick Herrick's on the team, Will Horton, who's the product designer for the last 10 years or so, and a great bench of people who've been working with XNAT in science for decades. And we are still working with WashU. The grant has transitioned to WashU, and we are the lead contractor on the grant. So we're in charge of the ongoing development of the platform through the grant. And Dan is still the PI. So still working closely with him to provide the kind of strategic direction for the project. So I think most of you may be familiar with XNAT. It was designed to be an extensible research informatics platform. That was always from the original design. It wasn't just an imaging platform. I know a lot of people think of it as an imaging platform. And ironically, the first versions of XNAT didn't have support for uploading or downloading files, which is pretty funny. We didn't add support for DICOM until maybe 3 or 4 years in. It was used for research informatics. So we were storing clinical assessments, psychometric assessments, as well as MR session and PET imaging session data. It's grown to include support for DICOM and connecting to a PACS, getting all of the data from a PACS into a research system, into a project-based architecture, so that data can be anonymized and shared out. A bit of history here. The project goes back quite a bit. I think back to about 2001, started in Randy Buckner's lab there at Washington University, which is where I was hired into in 2003. And there was an original version of a pre-version, it wasn't called XNAT yet, that Dan wrote, that I was hired to come in and help him with. And then we got funding to relaunch the project as XNAT, and I got to design and lead development of that, which was really cool. One of the highlights for me. It's had a long run. It's been the central platform for the Connectome DB project, Human Connectome project, which was great. We also have been running a large instance at Washington University for this entire span called the CNDA, which housed all of the research informatics data at Washington University in St. Louis. We merged with Flywheel there for a few years. The team got to be the largest it had ever been. And we launched a modernization of the platform, updating all of its dependencies, modernizing the back-end architecture, improving its performance, getting it up to speed for the modern workflows. And then finally this year, now we are joined between Washington University and XNAT Works, taking the project forward. XNAT has been a great ride here. It's been a great success out in the scientific community. It's used at hospitals all over the world and is used at most of the premier research institutions around the world to manage imaging data. It's been well adopted, has a lot of contributors from around the world who participate. So this is a brief sampling. It's not everybody. I know there's at least 2 in Brazil. So we're gradually adding them to this. And this is part of the challenge of an open source project, is that people take it and install it and use it, and we don't even know about it. I got a letter as part of the last grant renewal from a hospital in Sweden, and they had set up 7 of them in their hospital. I didn't even know they were using it. And 1 in each department, and we're putting all of their data into it, which is pretty cool. XNAT's used in a variety of different workflows. It's used in large institutions, major enterprise level grade XNAT, where it'll have 8 Tomcat servers and 64 gig Postgres, and large instances that are running in with high throughput, running 10,000, 20,000, 30,000, 40,000 jobs at a time through the container service. So it can be really big, but a lot of them are also really small, small labs at different research institutions, companies that take it and use it for different specific workflows. I love this slide because it goes back like 15 years, and it's cool to me that the workflow hasn't actually changed that much in 15 years. What we designed XNAT to do 20 years ago is still what we're doing today, which is part of why the project's still successful this many years in. So this is one of the slides Dan had to communicate what XNAT is used for 15 years ago, and it still pretty accurately reflects exactly what we're trying to do today. So XNAT's a great tool for ingesting data. We support multi-site clinical trials that are gathering data from a variety of institutions around the world using the platform, curating that data into project-based architectures, anonymizing the data as it's uploaded, doing annotation, compute. It's always been a compute engine from the earliest days. We had a pipeline engine that was used to run processing on your images. And then publishing results. And XNAT's been used as a publishing tool for data for years. We used to run XNAT Central, which was a great central repository. And so it's that was part of the original idea for the project, was to promote the open sharing of data, right? And so the mission of this conference is such an awesome fit and something that's right in line with who we are in the XNAT project. So the back-end design, I was the lead architect, so I always like to geek out a bit on the engineering structures. It was designed to have a dynamic data model. This was something that was a challenge to do back in 2004 with the programming structures that we had back then. The user interface was designed to be extensible so that you can plug in and modify the user interface at any point in the structure. It has a flexible search engine. That was actually the first part that I built back in the earliest days that allows you to join different data types together. So from the earliest days of XNAT, you could say, show me the subjects who have a CDR score greater than 0 and at least 2 T1 or 2 T2 images. And then from the very start, we always had a plug-in style architecture. We've done it in different ways over the 20 years, but it was always built to be extensible. And that, to me, is a fundamental part of XNAT. It's the X. A bit about the roadmap for where we are, the things we've been working on. A full upgrade of the Java version of XNAT. We've been stuck on an old version of Java for a long time, Java 8, so we've been upgrading to a more modern Java architecture. A lot of that motivated by XNAT being run in new compliance kind of structures. Dynamic data type definition, which I'll mention here in just a second. It's one of my favorites. And then a full upgrade of the DCM4Che library. So DCM4Che is the backend Java library for DICOM. We've been stuck on an old version of that, so we're doing a full upgrade of DICOM4Che. Next, the teams are working on a new version of OHIF for XNAT, v3, combined between radical imaging, ICR, and Washington University. There's a big project going on to provide a new version of the OHIF plugin for the XNAT. And then getting to DICOM Web and DICOM Services, which will open up the use of XNAT for writing medical imaging tools and allow for it to be used in clinical workflows a lot more naturally. And then continuing the modernization, upgrading our backend architecture to be supporting newer versions of Tomcat. And then going forward, it's about performance and new finding those additional tools that improve the performance of XNAT. So both increasing the size of the databases that we can manage, as well as tools like Globus to improve the performance of file management. And then, of course, UI modernization, which we're all eager to get to. So dynamic data type definition, this on the team, they say it is my white whale. That for 10 years I have been trying to figure out how to get to work in XNAT. XNAT has always had a dynamic data model where you could define new experiment structures and load them into your server, but it was always a build time requirement. You had to do it ahead of time and then restart your server to have your new data type in there. So what this is about enabling you to do that. Enabling you to do that on the fly. It takes less than a second now to create a new data type in XNAT. You can register a new data type. It can be a subject assessment or an image assessment for those of you who are familiar with XNAT. Easily define new clinical measures, new imaging analysis structures, whatever you guys need. You can create a custom form for it on the fly to model your data, which is common for a lot of our multi-site clinical trials. And then as soon as you've created it, it's now a fully functional data type in XNAT. So you can create new data types of that type. They're fully fledged experiments in XNAT, which means you can upload files to them via the RESTful API, and you can run containers on them. So you can add clinical measures, you can pull in all your clinical data from REDCap or from an EMR, and you can run containers on the clinical data, which is pretty cool. That'll be out in 1.10, coming out in the next month or two. In the new structure, over the last few years, we've been pulled, I would say, a bit more into clinical workflows on the XNAT team, and so we've had a deeper focus on clinical workflows. We're still deeply engaged in that, but we have gotten to get a little bit back to the science. And we've been engaged on several grants that I'll mention, which has really been a treat for those of us who started out in academia to get to come back and actually participate in some of that grant-funded work. So we're still deeply rooted in the neuroimaging community, but have definitely expanded out of that in deep ways. And then we work with a variety of clients around the world. Some of the largest cancer research hospitals are our clients, and we work with them day after day to get data loading in all of the CT sessions from their packs and running compute on them at scale. And then we run some of the biggest clinical trials in the world on XNAT. So PIXI is one I would mention because of the preclinical focus here. PIXI is a preclinical project out of Washington University that we're engaged on. It has already had one round of funding and has just been renewed for another round of funding, which is awesome given the current climate. They've modeled and modified the XNAT data structure so that it has species level information, animal level information for the subject. XNAT's extendable. You can modify to have any structure in there that you need to define. So the ability to define animal species, as well as built-in configurations for a hotel splitter when the mouse images come in with multiple mice in it and they need to be split out. And then different data types that have been added and custom uploaders for pulling in Excel files and putting that into the relational database so that you can query into it. As well as some fun Jupyter work. This is where a lot of the funding for XNAT's Jupyter plugin came from, was this project. This is what has really been a gift to the XNAT community for its Jupyter support. Oxy is a new project we've just been engaged on over the last couple months, so we're still getting going on it. It's one of my favorites because it's a young science, and it reminds me a lot of our early days, 20 years ago in the lab when we were working. It's been a lot of fun. So working on high density diffuse optical tomography, which is an area of science that I wasn't even familiar with. So these are the kinds of projects that we're engaged on, building plugins for XNAT to model their data and to make their research workflows work very natively. And then we run a 21 CFR Part 11 compliant version of XNAT. We have a version of XNAT that's gone through in-depth software validation, has a lot of features added to it, specifically for clinical trial work, so detailed audit trails, querying dashboards for tracking querying on data as it's acquired, upload tools for anonymizing data before it goes over the network, but then getting it marked with the right subject and visit and added into the right XNAT project, and then a lot of different configurable tools that are used on clinical trials around the world. Some of the features of XNAT CR, which is the clinical trial version, there's quite a bit. We've been working on this version for about 10 years. This was one of the main features of products at Radiologics, and is useful for multi-site clinical trials, but is also useful in a lot of the AI groups that are coming to us. They're trying to build AI algorithms for medical imaging. They realize they don't really want to build software for medical imaging if there's already something out there. So they're starting to use XNAT to do that. But if they're going to, down the road, get FDA approval for their algorithm, all of their data has to have been collected under a clinical trial regimen. And so they'll use the XNAT CR version of XNAT in order to manage all their data so that when they do to go to the FDA, it's been tracked and managed. I would say this is maybe one of our major focuses going forward at XNAT Works is compliance. XNAT's being used in more and more compliance-focused architectures in clinical environments and clinical trials. So this is a lot of our focus as we move forward, and we're looking at different quality management systems, even for the open source platform. So AI training and execution. We've definitely seen a big uptick in groups coming to us who are doing AI development and AI work for medical imaging. They're finding XNAT to be a great tool for organizing their data and building a container and running that on their data. So it's a pretty natural fit. We also have hospitals that are doing this in their research workflows. Pulling all their data out of the PACS so that they can train a new algorithm and hopefully get it into operation. It's been a really neat thing to see. So we've definitely seen a big impact from the AI work already, and I think we're still just seeing the tip of it. So our mission, we love XNAT. And we love the XNAT community. Most of us have dedicated our careers to XNAT. Many of us have worked on it for 20 years. The new guy is the guy who's worked on it for 5 years. There's a deep commitment to the XNAT project and to the XNAT community. And it's really one of the central missions for why I founded XNAT Works, was I wanted to make sure XNAT was taken care of, and that there would be an organization to make sure that happened, provide different funding mechanisms for the project, and also allow the developers to actually engage with the community in an active way, which I think is so important to software development, to try to let the people building the code interact with the people who are using the code is an important thing. And so, yeah, our mission is to keep it reliable, secure, scalable, well-supported, and free. I think that's an important part of open source science, and so we're doing our best to protect that for future generations of researchers. Why has XNAT been so popular, and why does it continue to be so popular? Part of it's the widespread adoption. There's an active XNAT community out there of people who have XNAT t-shirts and wear them, which is pretty crazy. More XNAT t-shirts than I have, actually. And so there's a lot of people who love XNAT out there, and so they provide a lot of support for the project and a lot of contributions to the project. And then it's an open source platform that has so many features built into it. It's been used in so many different workflows and customized for so many different workflows that there's often 2 or 3 ways to do anything that you need to do. So it's the versatility of the platform for being a free product makes it a very popular and something that is really something that the scientific community relies on. And then a lot of the commitment of the team, those of us who've been a part of the project and are still engaged and committed to it this many years on. That's an important part of the project's success. And then we do continue to have grant funding through a variety of projects and continue to have support contracts that we offer with groups that help to support the project. So different funding mechanisms to support the project is also an important part of how we manage an open source project going forward. So, and then it's been adopted in clinical trials and AI usage. It's a proven track record of having something that works and is out being used actively. And so, yeah, it's been a great honor to be a part of. This is from the last workshop back in 2022. We need to do another workshop. I would love to do a workshop in Australia. That's, I'm ready. And my team's ready. We would all love to do that. We love the community. We're people who do this to help the researchers. That's our passion. We build software, but we're doing it for the science and for the researchers. So we like to do anything we can that helps support them and allows us to engage with them and directly interact with them, which is why this is such a treat. So thank you again for the opportunity to be here. It's really cool. And yeah, thank you.